invitation, and thank you all for coming. Ladies and gentlemen, in life and in our work, failure is not the end. It is a step towards improvement. So today, we will look through some major accidents, how this philosophy has changed from a blame game to an opportunity for improvement, and the results in our business culture in shipping today. Something Socrates used to say is that true failure is not to make a mistake, but it is in refusing to learn and grow from it. It's quoted as falling down is not a failure. Failure comes when you stay where you have fallen. In the old days, companies were operating differently. There was when there was something bad going on, somebody had to take the blame. Today, the mindset is very different. Before, we would try to avoid challenges. Today, we view challenges as opportunities. Before, feedback was refused. Today, we ask for it. Before, we relied heavily on individuals. Now, we focus on the process. We used to feel threatened by the other's success. Now, we feel inspired, or at least we should feel inspired. In short, today, talent and generally the performance of all systems is not static, but we believe it is ever improving. There are many reasons for failures to happen, like we all understand. First of all, human error. Then there could be technical or design issues, maintenance gaps, communication breakdowns, and of course, external factors like the weather or unforeseen events. The modern approach is to investigate the root cause and so do what is necessary to eliminate that and take necessary actions. Over the years, many techniques and monitoring tools have been developed for identifying the root causes and then proceeding to actions, and corrective and preventive. So we all know today the ISM code and many inspection regimes like the Enhanced Survey Program used in shipping. The ultimate purpose, of course, is to turn damage into opportunity and improve, avoid repetition of the problem, and so build a stronger system. In our industry, the first step to actually start thinking like that was the Titanic disaster, which led to the first SOLAS convention. Following that tragic accident, there have been many more, which always have contributed to changes into the legislation and our way of working. Today, we all know that the ISM code is the main quality system used in shipping companies, but let's see why. Before the ISM code, we had about 20 vessels lost per year, which amounted to 82 deaths yearly. The actions by the IMO were focusing primarily on the technical side. At the time, Master was in charge as the top leader, relying on his experience, of course. The actions after major accidents were focusing on hardware, not addressing human factors and other reasons. At some point, they realized this practice can only get us so far. So they had to address the software too. Let's see three major disasters which led to this new direction. So the first one is the Herald of Free Enterprise. That was a Ro-Ro vessel that capsized at the port of Zeebrugge, killing 193 people. The reason, the silly reason, was because she sailed with the bow door open and started flooding, and the free surface effects created the capsizing, led to the capsizing. So, of course, the main lesson learned is not to sail with the bow door open, but of course investigation later showed other issues, like many communication problems. The next example is our Exxon Valdez that ran aground in 1989 in Alaska, causing massive pollution. The actual reason, technical reason, was malfunction of the steering gear, but the investigation later showed that lessons learned were fatigued officers, Master was drunk, not even on the bridge when it happened, and there were problems with the company's crew employment system and port operation system. So the third example is our Scandinavian Star, which was set on fire. It was a ferry boat which set on fire in 1990, killing 159 people. The main reasons were the crew again. The crew was not trained, couldn't even speak English or Norwegian or Danish. They were unfamiliar with the ship, and they never practiced a fire drill. The captain and the crew ultimately abandoned ship before everybody else, the passengers. And later on, of course, there were other reasons like design issues. There were many blind alleyways, and the materials would emit hydrogen cyanide poison when burning, and alarms couldn't be heard. So we see that the human element in those accidents was of prime importance. In fact, human error accounts for the majority of the causes of damage. But the good news, following the introduction of the ISM code, all the other monitoring and management systems used today, like the inspection regimes, the accidents have actually decreased dramatically, and the trend is decreasing. So drawing from the database of NK of about 9,800 ships of various types, let's see some failure damage examples and the way we handle them today differently. So first is a typical example, typical structural damage inside a double bottom tank in the longitudinals. So of course the obvious way to react is to repair locally, but the different thing today is to actually check for design faults. And of course, check management system defects, like if the vessel has been operating properly in her operating envelope during navigation or loading. So coming to a collision example with another vessel. So, of course, the first thing to think here is whether there was a navigation problem, a navigation error that led to this collision. So, as a standard response, we need, of course, to check the management system again to see if the management system covers the proper navigation details and, of course, if it was properly implemented. In all cases, we always check how we respond when something goes wrong. So the main lesson learned here would be to check our emergency response and have a plan for each case. Another structural damage is an explosion in the bosun store because of storage of some volatile material like solvents and paints. The main thing to check again is the management system, whether the main lesson learned, whether the management system was covering proper storage instructions and whether that was followed. Coming to machinery damage, we have a buoy caught in the propeller causing damage to the stern tube. Again, navigation is the first thing that comes to mind as the management system, whether the management system would cover that. But most importantly is to check the reaction procedure, the emergency response when something like that comes. And unforeseen events like that, they're not uncommon, so it's important. This is a case of fuel oil which could not be pumped as it became solid. So what happened when leading to the vessel running out of fuel? What happened was the vessel bunkered its fuel, a VLSFO, with properties which were not probably taken into account by the crew. This fuel has a very high pour point, which means that it needs to be heated. When vessel tried to use this fuel, couldn't even heat it, so ending up with the fuel unpumpable and running out of fuel. So again, the main lessons learned is to give proper instructions to the users, to the crew, and checking that they follow properly. Coming to our last example is our stern tube damage. Which melted, which was destroyed. The actual reason for the damage, of course, actually the lesson learned here is that we had indications about the empiric damage for the last 2 years. The oil samples were telling us that the tin percentage was very high, meaning that there was a damage coming to the bearing, but they were not taken into account. So So, of course, the lesson learned here is to check the management system regarding the training of the crew. So something to take away with you is that failure is not part of the process. It is only part of the process to learn. And today our industry has become safer and has a way to properly handle everything with all these systems. And of course, thankfully, this situation will continue to improve by continuous monitoring of those principles. Thank you very much.